Hello. If you want to launch a spacecraft, which launch location and launch direction should you use? Today I'll show you the issues involved in making these decisions. Have you ever wondered why the NASA launch facility is in Florida, USA? The reason is that it normally takes less fuel to launch from there compared to other locations further north. Consider this. Earth is rotating easterly with rotation axis that passes through the poles. If you're standing on one of the poles, you are rotating but have no linear velocity relative to the center of Earth. I show this in the current video where your location is indicated with a white sphere on the surface of Earth. However, if you're standing on the equator at sea level, your linear speed in the eastward direction relative to Earth's center is high, about 465 meters per second. The closer you are to the equator, the higher your linear speed. This occurs because you are further away from Earth's spin axis. I show this in the new video where the white sphere indicates your position on the equator. Obviously then, if you launch from near the equator and in an easterly direction, you have some initial velocity, and that initial velocity represents fuel saved. Florida isn't exactly on the equator, but it's close enough to get some benefit from Earth's rotation. The European Space Agency's launch facility is in Kourou, French Guiana, for the same reason. The complete equation for initial easterly velocity as a function of latitude and distance from the center of Earth is given by the following equation, where RE is the distance to the center of Earth. On the equator at sea level, the latitude is 0 degrees, and the easterly velocity relative to Earth's center is 465 meters per second. At the North Pole, the latitude is 90 degrees, and the easterly velocity is 0 regardless of altitude. If the launch facility's latitude is 28.5 degrees, the easterly velocity is 408 meters per second at sea level. This is the latitude for Kennedy Space Center. The altitude at the Kennedy Space Center is about 0. But is that the altitude we should use in this equation to find the initial boost in speed? It might be better to use the altitude where the rocket exits the atmosphere. If there is no wind, the atmosphere will be traveling easterly with Earth's rotation and will push the rocket faster toward the east as the rocket gains altitude. Seldom do we launch due east because that limits us to a single orbit inclination. If our orbit inclination is to be, for example, 30 degrees, in what direction should we launch? Since launch azimuth and orbit inclination are not the same, but are related, we must calculate the required launch azimuth based on the desired orbit inclination and launch location latitude. If we ignore Earth's rotation, that equation is the simple one I now show and provides an approximate value. In this equation, beta is the launch azimuth required, I is the desired orbit inclination, and LAT is the launch location's latitude. If you want to be more precise and include Earth's rotation, you must use the equation I now show where we use launch azimuth from the previous equation to find a more accurate value that includes the effects of Earth rotation. If you want to launch a spacecraft into a 30-degree inclined orbit from Kennedy Space Center, where the latitude is 28.5 degrees, and you ignore Earth's rotation, these equations require a launch azimuth equal to 80.29 degrees. However, if you include the effects of Earth rotation and assume an orbit altitude equal to 200 kilometers, where the orbital speed is 7,187 meters per second, the equations require a launch azimuth equal to 79.67 degrees. The difference is almost insignificant. If you desire a polar orbit, where the inclination is 90 degrees, Earth's spin direction does not benefit you. However, you do need to take this into account when choosing a launch azimuth. Based on the last equation that I just showed, you must launch slightly toward the west to compensate for this. Thank you for watching this video. If you find it useful, please give it a like and consider subscribing to the channel. If you want to be notified when new content is added, click on the notification bell. We also need your feedback, so please leave comments. Goodbye.